right, back again. Still looking at graphs. Still again, and the first thing we're going to do is determine what type of graph it is. It might not always be distance and time, but determine what type of graph it is, and it's still a distance and time graph. Sketch a graph that shows someone walking slowly, stopping to get on a bike, riding away quickly. Now, this goes back to our last graph. How am I going to show someone that's walking slowly? What would my line look like? Parker? Yeah, not a very steep line at all, right? So I'm going to walk slowly. Then what do I do next? Bianca, what's the next step? Someone walks slowly. Then, what does it say? Stop to get on a bike. What would that look like on this graph? Stopping. Yep, they're at rest, so they're straight line. Now, when I get on a bike and I move away quickly, am I moving faster than I was when I was walking slowly? So should my line be less steep or more steep than the walking line? I should have a steeper line leaving. So there we go. If I go back and I look at it, someone walking slowly, someone stopping to get on a bike. I have someone, once they're on the bike, riding away, obviously a lot quicker than they were walking earlier. Questions on that one? Questions on that one? So we're having, I think, a great conversation about why we didn't do a specific type of line at the end of this. And again, if you put that acceleration on there, you're right on the bike, that's correct. But what I really like is if I take my line of my bike, like we've done in here, and I move it over here. Now it's comparing those two lines, and we see that this line is way steeper than this line, which means when they rode off on the bike, they were riding off at a faster rate of speed. I like doing it like this because it makes me think about the graph that looks like this, maybe. There we go. I'm going to use the pen. Remember we had this one earlier where we were comparing the two? Right? I like the fact that I'm able to take this line and move it over, and it looks like I'm comparing the two lines. Because that's really what you're doing in this one. That's what they're really trying to get you to think about. Does that make sense? All right. Any other questions on this one? Great conversation. All right. Can I clear it? All right. Last one before we jump into our social studies project. Sketch a graph. Okay, and this I will probably be doing this tonight. Sketch a graph where someone is accelerating from a red light and then gets stopped by a train. I can see the red light I'm going to be at right now. I go through that red light. I try to speed up so I can get going down the road towards my mom's house, but there is a train track there, and very often the little ding, 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 the lights start going off, the big giant arms come down on both sides, and the big, huge train goes by. Very cool spot for me. That's where my grandma used to go with me because the train would go by a lot, and she would take pennies. Tell me if you've ever done with a parent or grandparent. And she would put the pennies on the railroad track. And the train would go by and run over the pennies, and it would flatten the pennies. Has anybody in here ever seen that? Just two people. Boy, oh boy. Let me see. I'm going to pause this video. I'm going to see if I can show you that. Maybe pause the video if I pick the right. All right. Sorry about the trip down memory lane. Apologize. It was really neat thinking about that. I need to show someone accelerating. And we remember we're looking at a distance time graph. What does acceleration look like on a distance time graph, Dalen? It's that curved line. So I have someone, man alive, Mr. B, get with it, accelerating. But what happens to them? What happens in the green portion of the story, Xander? What does it say? I've accelerated, but then how do I show stopped or at rest? Do what? How do I show that? The straight line. And again, every time I draw this, I feel like I'm drawing a division equation. 4 into 8 is 2. It looks like it, doesn't it?
Yeah.
That's what it looks like to me every time I draw it. That's what I've thought about all day when I've drawn this. Now, if I go through this, and I like to do this in my head, and you should do this. I am accelerating. Did I get that part correct? I did. Then I get stopped by a train. Does that make sense? That was kind of easy, right? But boys and girls, when we first started this, there's no way I could have shown you that and you couldn't have done it. Look at how much you've grown since the first day at looking at these. And I can tell you, it's very obvious to me the people that are studying their graphs on a daily basis versus those that aren't looking at them at all. It makes a big difference. In my morning groups, I had a kid get all of them but one correct. She has been studying. It's obvious. Her hand goes up before I can even get the question out. She's been working on them. You have to go home and do these daily. Even if you just sit down and draw them, drawing them out, Bianca, draw all 7 graphs out and label them and then flip the page and then do it again. Getting used to getting very fluent with that's going to make you much better. Any more questions on this? Can't believe that we've knocked out 2 videos today, so we're going to pause this guy and upload it to YouTube.